think beyond that?
We are from Knowledge Institute of Technology, the students of second year Mechanical Engineering Department.
So, this is our cycle. Coming to the team objective part, firstly we did, in the innovation side, we had done the part that two-way handlebar. We made it, the handlebar, easy for the normal roadside drivers, and also if we go to a long drive, we can use the handlebar downwards. It will be useful for we made both in both roadside and also in both mountain bike side. So this is our first innovation, and also in India, it's hard to take cycle while parking the cycle. Also, it made a little bit difficult. So that we made like a gripness that is fingerprint imprinter in the frame part that makes actually easiness for carrying the bicycle. So
okay, that is provided only for lifting.
sir, this one. Sir.
Ah.
Yes, sir, for gripness we
Grip for lifting.
yes, sir, for
It's
easy.
difficult to take to upstairs, sir. So we have made this impression so that it will be easy for us to take to the upstairs.
That I agree, but
Yes.
will it add weight to the frame on the side?
Sir, a bit weight, sir, but it's easy to carry. Sir.
It's only for that purpose, right?
Yes, sir.
And you have given this, and then you have two tubes,
So
right?
also for strength we welded this part.
Yeah,
Sir.
correct. My question is, the weight should be light
Yes, sir.
for us to easily commute, right?
Yes,
That's
sir.
a purpose. So there are, I could say, 3 tubes are there
Yes, sir.
only for this purpose.
So actually we made first only 2 for design purpose, sir.
Oh, okay, I would suggest this way. You can think of any lesser weight material or non-metal. Just think of it.
Yes, sir. Also we planned like rubber only we first try to plan, sir, but for molding, welding purpose it will heat, so that we made this in steel. Sir.
It's not given for the structural strength, correct?
Yes.
It's not given for that purpose. It's only for lifting, right?
So for lifting, yes, sir.
Okay, please.
Next, let's see the challenges we faced. First is the frame design and also making two-way handlebar. It was first we didn't have this idea, but while we are discussing with our friends, we came to a conclusion that everyone are using now single side handlebar. We have seen now. We haven't seen like this. So when our riders, when they were practicing, we were practicing motorcycle. So when we were doing that, it was like difficult for us to handle. So we had an innovation idea. Okay, let's do like this. So we have done it. So that it will be helpful for us, like a normal human being also, and for the riders also it will be useful. So we have been.
Okay. How will you apply the brake to use other brake?
So brake is also we can tilt it down, sir. So we can also use it like this too, sir. We didn't make two because it's bit difficult, so that we just made it upwards for in roads, normal roads. Sir, if we want to go long run, we can use like this. Yes.
You understand my
Yes.
question,
Yes,
right?
yes.
You're driving like
Yes.
this, and brake is a thing which has to be applied immediately, right?
Yes,
That's
sir.
a purpose.
So when the
Will
field
you be able to? I mean, will you have the time to?
So no sir, when we are riding for a long time, we have some hand pain, no sir. So for resting for some while we can use this, sir. And when it's okay,
By the way, I appreciate that design. First, that is good. I'm asking one more question. That's all. Think of it.
So while making the bicycle, the lessons we made are how to do. We had learned a lot of things from we learned from scratch to a complete bicycle. Firstly, we learned how to do like even though some say it's a simple cycle, but there are a lot of challenges that we faced from since starting to till now. We made complete. It was a bit complete difficult while doing the manufacturing process, and also we learned how to make reports and how to do calculations while making the cycle. And then we also learned how to while completing the cycle. In the E1, we have mentioned we take guidance from our seniors too. Also, while doing E1, we learned how to do it without like adding all the bill of materials. Well,
Next.
This is not yours.
Yes, yes. Sir, this is a team based, sir. So like a girl from how the girls were, sir. So they were not allowed to study or they were not allowed to go somewhere, sir. So from there, a girl started to
How
work.
you
We
emerge?
yes, sir.
Woman empowerment, sir. How woman empowerment?
So like
Also,
So finally you are here?
no, sir, we
Fighting.
Not that.
So like going colleges, fighting for their life, struggling in the life.
many people demotivated and also didn't get an education a lot, but now we are directed to say
Given
we are
many
empowered,
obstacles
so that
right
we
sir,
are.
for us.
All mechanical.
Yes,
Yes,
sir.
sir.
This look,
Yes, sir.
it's good to see. You know, when I was studying in 1987 to 91, I did engineering, and I used to, we used to have only 3 girls, but 3 girls were done in mechanical. Now I could see one class.
Yes, sir.
Great. Proceed.
Okay. Next, let's see the vehicle specification. The first one is the top tube. It is of length 500 millimeter, and also next, let's see the saddle. It is of diameter 35 millimeter, and also let's come to the tire. It is of diameter 335 millimeter, and also from the center of the tire to this length, it's of 580 millimeter, and also this drainer, it is of length 470, and the fork is of length 415. Oh, that's
So, firstly, while starting our cycle design, we come to the conclusion that frame part should be in a normal, we made a line bended frame in the starting stage, but after so many ideas, we came into the conclusion that we have to do something different in the frame, so that we made that had like thickness in the middle of the frame. And here comes the frame part.
These are our bicycle features. It will be a simple and elegant, and also efficient power transfer and lightweight design, and ideal for smooth roads.
We didn't have suspension in the bicycle, but our bicycle is a roadside bicycle that is easy for both road riders and also for long-term riders too. And then in the brake system, we used to V-brake. We first prefer disc brake, but due to some while performing the conditions, also we made frame. It was a bit difficult for us to do disc brake, so that we came into the part and we conclude that V-brake is best suit for us to perform, so that we made V-brake in our side.
You said it is for the road, it's a road bike.
Yes, yes, sir.
Road bike, I have not seen this kind of width tire. Usually the tire width will be less.
Yes.
Right? Correct?
Sir, so because we here made handlebar convenient for a long race, so that we did a little bit bigger ones.
This is a question I have. I'm asking you. I am your customer.
Yes.
I'm asking. Road bike is what my understanding. Usually it will be very
Yes,
thin
yes, sir.
because less friction. Here it is. You have more surface area of contact. Again, you have to work in the friction. You have to give more calories burnt.
Yes.
You can say that this will be good for the exercise.
Yes, sir.
Of course, it will be good for exercise.
Yes,
Oh,
sir.
you're right. This one.
Next, let's come to the steering part. As we said before, we have made a two-way handlebars, and we can hold both upper side and also in the lower part, and it will be rotated in 90 degree or 180. Sir. We can rotate this.
What is the purpose? Why it should rotate 180 degrees?
So it will be convenient. So while turning
Turning or something.
You create accident. Right?
Not
more, sir, but
See,
we can tie it.
yeah. See the control, yes. just misses out, it comes like this, whatever. Running
So the driver's control, sir.
depends on the
Driver's
driver's
control.
control. Correct, but you know about our mind. Goes this way, this way, 360 degrees. In spherical direction, not in plane. Spherical plane, mechanically you understand. Spherical plane, you know, so many planes it our mind will do. So there is a reason why it is controlled. Even in two-wheeler, now I'm talking about automobile, the area of the turning, what is the maximum angle it can turn? It is locked or it is given for a particular angle. The reason is this. What is the reason behind it? Please go ahead.
Yes, sir.
Go ahead. It looks like for me it looks like a blue. What is it? Yeah, it looks like a blue. Just see this. Can you see that? It looks like a blue. With the blue horns.
Yes.
So, transmission power. Normally, like all the other roads, cycles, the transmission power comes from both drivers in front and the back drivers, and also it comes from the chain and the cassette part, and then transit. So wheel assembly, done by rim and then spoke, and in the hub we made it like.
Wait. Transmission power. How the transmission is happening, right? That's what. How the power is transmitted. You just explain from there. Why you have to see it?
Yes.
You give the power here, right? You torque. Exactly, it's torque, right? This is force during this radius and this is torque. This is transmitted. This and this is this. That's and because of that, this is also.
So from front trailer to back trailer, the chain is rotating.
That's all.
Yes.
Cassette is what?
So this one.
Free will.
Yes.
Free will you're saying cassette.
Yes.
Chain. Okay. So it's a chain wheel, there is a free wheel. The power is torque is transmitted from through the crank, chain wheel, chain, free wheel, the rear tire, rear wheel,
Yes, sir.
front wheel.
So,
Okay.
Okay, next let's see the CAE process, that is a computer aided process. First we made our design, and we made our design specification what we needed to do in our cycle running diagram. And next we have verified our designs, and we have loaded the application, and as a final result we have made our cycle. As I said this, we have done this through a gas valve only. This impression is created.
The CA process itself, we made first different frame, but we made the conclusion that we are not okay with the result, so we changed. Another time we had not okay with the result, so that we again changed it, and the final outcome has come in improvement. So now coming to the
So CAE, I mean, it's not, it's under CAE it is FEA. What you guys did is FEA, finite element analysis. That's what we are doing. CAE is a little bit dumb. It's okay. So you did it, you did the iteration and it was not okay, and then you did the correction in design, and then
yes,
this
sir.
is what we
Yes,
see
yes,
is the
sir.
final.
Yes, yes.
So coming to the cost and analysis part, while doing Bear cycle, cost part is a bit difficult because we asked suggestions from our seniors too. They had suggest all some outside materials that we have to buy. So after concluding everything, we came up with the price of between the price of 3,000, and then. And here comes our second. And we added ECOM or ECOM here so that we can finalize the cost of the product.
The cost of the products is for we have done is this cycle is for 2,880 rupees.
So finalizing the cost, we checked the rule book. In the rule book, the prices were calculated as per the guidelines given by rule book. It was of 40% cost of we buy raw materials and then 70% of retail price. So that also the price comes fall under 2,880 and we finance it in our ego. Also, we have practically tested the weight test in between our manufacturing.
First, our project plan was this. We had a mindset to do the frame in this method. But after the discussion, as I said before, with our friends and our colleagues, we came to a conclusion that we can make. We had a, as I said before, only it's difficult for us to carry somewhere, or it was, and also for the handlebar, as I said. So let's make us let's change our mindset to an innovative one, and we have made this. And our project plan is changed to this, and this is our cycle. Okay, next let's see about the design, manufacturing and the assembly. First is the initial frame. For normal riders frame with only one product, we have maximum we have seen every cycle. Here for maximum cycle we have seen meat from morning. It was only it had a one handlebar. But we have done but our final frame had been designed in this way, and our handlebars is also changed in this way.
You know what is DFM mean?
So design, manufacturing and assembly.
Design, failure, mode, effect analysis. This is done when you do the first design, before even you get into the FEA. Clear? FEA is done once this gets mature, you do the FEA. By FEA, you around 60-70% of the design is freeze, frozen. And then you do the fine tuning and all, finally you get the elements and what you see. That's a process. Go ahead, please.
So coming to the innovation part, in the starting we said we made three innovation. The first one lies in the handlebar side, like we had made upper and lower handlebar, and then for the second falls on the frame part. The first one falls on handlebar part, and the second falls on the frame part. Like we made it fingerprinted in between our frame, and then also the seat is adjustable.
So next one.
This one.
Yes, sir, this one.
Vertically adjustable.
Yes. Sir, normally up and down.
What of design? You know what is the meaning of innovation?
Sir, new thing. So the first two lines.
Okay. Again, how did you make that impression?
So
Sir, gas welding, sir.
So also we can see only this automatic. We have bended this.
Only in
You can
automatic
see
cycles
only
we
in the
can see
automatic-
here, sir. But we were the one we done in the normal cycle, sir. In automatic cycle we can see.
So automatic cycle means
So
E by cycle.
no sir. So we can see only in the automations like how can you see sir?
No. I'm not getting it.
So we can't do it in a single tube, sir, but this is made in a single tube.
So
You are
we just
saying-
bend it
you
sir.
are saying the
Bending-
manufacturing process.
Yes sir.
Okay, you made it. You
Yes.
did the bending. You
Yes.
did this bending.
It's all by us.
I want to ask what you guys did. These two lady gentlemen talking. Talking. These are not talking. Sometimes she's talking. These are not. I will talk.
Yes sir. We split it up sir. So we all share the work sir. So
What you did? What you were doing?
sir, I'm the driver.
You are the driver. You what you are doing? Assembly and disassembly. All three experts in assembly and disassembly. Driver expert.
So she could write. She
Driver.
You also driver.
Yes. She's a captain and she's vice captain.
Captain as captain. You do the complete.
yes.
So okay, fine. Is the work that's is the presentation over?
Yes, sir. Yes. So final product display.
Final product display is here.
Yes, sir.
I have
Sir,
seen that. Okay,
sir, that's
fine. What is the weight of the frame?
sir. 15 kg.
I saw there was 8 kg written. 8 kg written.
So she told that
Overall weight
Overall
she
today.
No. Frame weight is 8 kg.
8 kg.
Your presentation, I
Sir,
don't.
frame
Frame
is
is
not a
So today we did weight test, sir, so I said that weight is
I'm sorry. I didn't
Sir,
get
she told the overall weight, sir.
it. Overall weight is how much?
Sir, 15, sir.
I know. The frame weight itself is 8 kg.
Yes, sir.
8 kg frame weight is very heavy.
Yes, sir.
You know where it comes to those 3 pipes.
yes.
You know, my guess. Another thing is, yeah, otherwise it is okay. For, you know, those 2 are adding extra weight. Okay, fine. So you have the same. See, the seat I'm not considered as a
Yes.
very it's there in every cycle, every bicycle has it. You are saying information handlebar is okay. The handlebar lifting is, I would say, it's a overkill. Meaning, it's expensive for us. If it's a new thought, it can be done in a better. Okay, thank you.
Thank you, sir.
Represent the Rajiv Institute of Technology, Kottayam. First of all, I will introduce our teammates. Indran's Vice Captain, Venkatesh, Vinay Matthew, Joe, and Adilajit. And there is another team member, his name is Afnas. He will be reaching tomorrow morning because he is having an examination. Okay. Next. What's next? Okay. When we created the team, we conducted a team meeting, and this was the first preliminary idea that we suggested a monochrome design with a foldable one. After that, we come to the workshop and gain some knowledge about it, and then changed our plan to a double type design. That is this. So it was after that we changed our plan to this design, as it is the most effective one in terms of load distribution and other factors. The material used for the frame is GP. Galvanized pipe is used for the frame material, and the metal joining process is here usually stick welding process.
Take the
And about the steering, here we used a straight handlebar and also a threadless core assembly. Using ball bearings for easiness of operations. And also suspension that we use is a telescopic suspension with a travel of 100 mm. And moving on to the brake, here the front wheel is accompanied by a power brake and a disc brake, a combi braking system. Here we use a combi braking system. And also the rear wheel is accompanied by a power brake.
e-brake.
Yes, brake. So that is one of our innovation. Like when you
Why do you need these 2 brakes?
for better braking.
This brake itself is a effective brake. This brake itself will be very effective, right?
Yes.
So this brake itself is effective, but as of the place we regularly travel, we need that much more better braking force.
Also hybrid bicycle. So
For city use and just normal use, this brake is effective. But for the people who use hilly areas, when you listen, you can see that this brake is not much more effective. You need more force, braking force. That's why we use hybrid braking.
a dual braking system, a combi braking system. It's accompanied mainly by this. So moving on to the transmission, here we use 7-speed transmission with the number 44 in the front sprocket and the freewheel of 48 to 28 feet. And the gear ratio, here we use this 2.4 and the chain length of 140 cm. As I mentioned earlier, the front wheel is powered for the easy dismantling and assembling Both of the wheels are provided with a quick release mechanism. Okay, and as I mentioned earlier, the rear wheel is provided with a wheel brake system, and the front wheel is provided with a disc and a wheel brake system. Go on to the
Good afternoon, sir. My name is Krishna Gaya, and I am the vice captain of this team. My main part of the contribution to this team is that I did the CAE process. The analysis part was done by me. As you all know, the bicycle frame is designed based on the weight and based on the weight and
Load cases. We are going to give a load cases for the frame where the loads acting, and based on that we want to see the deflection and the stress, correct?
the bicycle design frame and the material used plays a major role.
What is the material you use?
There is actually an error in that it's not actually designed, it's
galvanized
galvanized.
pipe. The galvanized pipe is used.
GI pipe.
Galvanized pipe.
Galvanized iron pipe, correct? That's what we are using.
After conducting the analysis, the maximum deformation is uploaded at the
State.
state.
And you can see that the minimum is on down view. It is blue color.
It is happening at the seed state. That was the central point. How come here? My little knowledge also. See, acting. Both sides. Correct, that's it. Maximum deformation stress. That's a deformation. Deformation, why does that happen? Yeah. You know how it happens? Can you go back? Why it is happening here? When you will fix this point in the FPA, you are in the load. It's a load here. Because in the load here. Now when it is fixed, you give a load. It's a little the shape. It's a triangle buckle. Comes outside. Do that. It's not direct load. From there, you try to, and then it's fixed. You try to come down, which means this length is there already, but you try to push down. This length, this goes down. This is becoming less. This is becoming less. But it has to be compensated somewhere. Okay, fine. Go ahead, please.
The bicycle frame design is actually based on weight. We can say there involves frequent use of high performance material. So the material we have taken here is GP, galvanized pipe. For the riders, energy consumption, we have chosen the best bicycle frame design. And the methodology I did the analysis using the ANSYS workbench. Methodology I am taking first of all the engineering data that the material is selected and the Young's modulus and Poisson ratio is defined. And then
What is Poisson's ratio?
Poisson's ratio.
Don't ask these questions, right?
Ratio plan plus
Lab use plus 2 lab use to
What is it? Come again?
is the ratio of
Lateral stress by
loss of units to.
No, honestly, I forgot. I'm asking you have done this. You said that. I had to Google this. But you said no. I thought you would know. Clearly, you don't. You go ahead. Serious?
And then the model, I have inserted the coordinates to the all points and then connecting to a 3D frame. And then the third step, I set up the conditions for the model, and then the setup, the fixed support and the point forces are applied, and then the solutions required are chosen, and the final results are obtained. Before
Strain. What strain? Not strain. Axial versus transverse. The opposite this direction, this direction. Strain and this direction. It's very important parameter for the analysis. Concentration for any material. Okay.
before doing the analysis on the bicycle frame, to check whether the software results are accurate, approximate, we did an analysis on the simple mean, and after doing a manual calculation, we came to know that the results are approximate.
Two of you to go for a team, one to attempt. This
These are also the four presentations. After that,
you finish almost done.
almost done.
Finish and
This is a cost and weight analysis. This is a cost and weight analysis of the previous team that had completed the bicycle design competition last year, and those were a single transmission bicycle. Our are a semi-split transmission bicycle, and our cost and weight analysis. The total cost went up to 8,410, and the total weight was about 18 kgs. Ours is a 7-speed transmission bicycle. Our constraint was up to 10,000, and we met the constraint. Our approximate total cost was 9,100, and our total weight after the weight test conducted today was 17.74. And this is the project plan, also the actual plan of our bicycle. Next comes the design, failure mode, and effect analysis. Design failure happens with design in the product. Design fails to meet its requirements, and the intended function is not met. We have conducted a design failure mode and effect analysis of frame and brake lever. For the frame, the potential design failure analysis helps us to identify the potential failure mode and to identify the causes and the potential effects of that failure, and to detect those causes and apply our current design controls to detect them and find the risk priority number. So for the frame, for the potential effect of loss of control due to material cutting or corrosion or improper welding, the severity number was 7, which is about approximately height.
So this is fine. I understand this. When, what stage you did this analysis? This
After the design process,
after the
after the design,
after the FEA.
after the FEA, PFEA, it comes the DFEA, and
No. This FEA whatever he has explained. What he has explained. Structural analysis. Whether this is done after that. When, what stage you did this DFME?
FEA after FEA.
Okay, I'll tell you. This has to be done in the initial stage.
PFEA is done before.
What is DFE?
DFEA, product failure.
You're talking about DFMEA.
Yeah.
So,
I had learned that BFMEA is done before, during the design and analysis, and DFMEA is done after the manufacture.
what is another one is PFMEA.
PFMEA,
That is process.
process failure mode and effect analysis.
First is design. After that,
Yeah,
process.
from SAEISS, I learned.
It is first activity. Because what will happen? You have done the FEA and you have already fine-tuned the design. Then you do this. Here you will find out more process. That has to be incorporated in the design. You have to change the design. Again you have to do the FEA. Understand? First level you have to do. When you start with the design, with the first design you have to do this. And then improve the design. Arrive at the kind of a 60-70% of the good design, and then do the FEA, iterate it, reach 100%, final design, prototype. That's a process. Anyway, you can move on. I'm just giving you the process. This you don't have to go through. I understood.
After the DFMEA break,
So this each and everything you guys you have done this. Each and everything.
some of them we have learned from the previous teams. Validation.
Okay. This priority number you assign.
Yeah. Comes the DVP. DVP is a design validation plan where each of the components are being validated by different methods, visual inspection or demonstration or using modeling, simulation, and
No. Validation means it's physical testing. What are the tests you do for a particular component or a complete product? Complete bicycle in this case. It could be for the frame, for the handlebar, for the saddle, for the brake. Okay, or complete bicycle.
validation using calculations.
No, design validation is physical test.
But simulation also, simulation modeling also.
Simulation is the FEA. FEA is nothing but simulation.
What I have learned.
Okay, what you are saying here? You have written there. Validation method is conduct brake test. You have written.
Braking system is brake test is a actual physical.
Correct. For the brake lever, you are saying visual inspection. Say visual inspection is you will see only aesthetics, thickness. But whether the brake lever will handle the particular load and will withstand this the load conditions, whatever we are proposing to, then it has to be tested physically different. Or it has to be done by the supplier. Or you say that the DVP done by supplier. Because it's a supplier is giving that. He has to do it and do it. Those are the process.
Testing facilities or
No. I'm just telling you what happened. You guys cannot do this. Even we do.
some from our previous teams.
I understand. We do.
Same similar design is coming.
Understood. As a TS cycle, we are doing this. Okay, move on.
Then comes the innovation. We have incorporated two innovations. One is the combi braking system. As already have mentioned, we have incorporated a combi braking for the hybrid bicycle for better braking performance in versatile applic conditions, like including the features for a necessary features braking necessities for a mountain bike as well as for a city bike. Next is the internal cabling for integration of an internal cabling routing for better aesthetics, aerodynamics and protection.
Internal cable routing, you're saying internal brake cable routing.
Yeah.
You're saying is an innovation.
It's kind of a new trend and
Training.
improves the aesthetics and
I understand.
normal better aerodynamics because normal tubular creates turbulence. So better aerodynamics for hybrid bicycle we have proposed.
We are most of our bicycles we have them.
Indian cable.
We are implementing.
And now it's a trend.
Earlier also there, but not in all models. Some
No.
models. Anyway, go ahead.
So
That's a team. Where is that your college?
no, just today.
Here. I took a photo and put it at the presentation. So fast here. Okay, it's 7 people.
On his apps, yeah, will pretty small.
Okay, fine. I think I have only this question only. Right. I don't see the need for it again because I don't see any complaint or I have not received any complaint with the disc brake system.
Disc
It
brake
is
system.
effective.
The disc brake system. So what we have to do in when we have to service this, you have to replace the whole brake system itself. They won't give you the brake pads. In this case, even if the disc fails, you can still have a brake there.
Yeah, disc brake system you have that you have that caliper, right? It's a disc.
Yeah.
This is called caliper, but anyway here I am saying in the car now what we see. I mean the two-wheelers cars and all, we see the caliper brake.
Brake pads.
This could be like this. It could be like this. So that portion is there and there it is going to be like the pad.
Yeah, the brake. You can't get the brake pads if they worn out. That's the whole issue with this brake. You have to change the whole brake caliper.
So you are saying that this may go up and then you will replace it.
Yeah, that's a regular issue in the high steep areas where you use disc brakes. You have to give heavy load on the brakes and they will not too fast.
So you are introducing this to improve the
Brake effect.
and the life of the
Brake.
brake system. Okay.
In this system, the disc receives less load, and both the brakes will get enough life. Long life, you can see.
Okay, fine, got it. So I'm done. Very good. All the very best.
Thank you.
Thank you very much.
So our team was to manufacture an aesthetically pleasing, budget-friendly, ergonomically stable and extra utility space for rider. This was a major aim we started to discuss and actually end up in this cycle. So these are the challenges that we faced. There was another team back here, so we discussed with them what was the struggle that they were having. So they gave us advice, and these are things that we found that difficulty on installation of this shock. So installation of shock was one of the difficult things. Proper suspension travel and climbing of the monoshock. These are the things that we found difficult in this work. Early idea pitching and better planning. These three things that we got advice from our later faculties. So these are other things that we lesson learned, and early idea pitching helped us to execute this cycle faster in a faster way. That's it. So
As you have seen, cycle comes in my shop and
One shot.
yeah, so, and then integrated storage system.
Monoshot. Why monoshot?
Why monoshot? Because in the international market there is a cycle called Lefty. There's a company called Cannondale. They produce a particular cycle called Lefty, which is a mountain bike. So that comes with a single shot. So I thought our team thought, why can we execute this?
But this too, I know, it will hit the handlebar. Right? It will hit the handlebar. No?
No.
Also, during the travel, this
Actually, we put a clamp here and here.
this will take suspension travel
travel.
when we during the
It's fixed.
yeah. Actually,
Prevent the rotation.
Okay, I can try that. In that case, okay, it's a really prototype. We use this. Use some.
Yes.
You can make a group of this. This portion will make it beautiful. So like this. Okay, prototype will be like this only. You cannot make a perfect.
We actually got 1 week to complete this project.
yeah,
So,
same
very, very fast.
also 2 months of difference.
No, go ahead.
Next. So this was a phase of our design. First was concept development, structural design, ergonomic consideration.
What is ergonomics?
Ergonomics can be defined as how comfortable a rider can be.
It's basically designing of a structural component in the terms of human beings.
Human
length,
comfort is actually
without affecting.
like fatigue.
Fatigue.
Things happen while they ride.
Okay, I'll put it this way. It's a connection between the man and the machine.
Oh, yes, sir. So,
Machine. Okay, my background was machine. Now I'm in bicycle design. In this case, it is a mobile machine that is bicycle. So connect. Holding the handlebar like this is okay, comfortable.
yes, sir.
Like this is okay. So these are the things, like the height
Yeah.
and the stretch. This is comfortable. This is not comfortable. So ergonomics is even the foot inside the machine. Okay, we'll say
Yeah,
that.
so we
Lot
are.
of, say from here to here, the loading in the machine, 350 mm if I remember correctly. My body to this 350 mm. It should be. The loading, I'm just saying,
Yes.
350 mm. You cannot look like this.
Sir, actually, we try to implement in an upright position.
To maximum
Comfort.
So this was a phase of our, this was a pattern that we followed while executing the. So suspension, there was a slide actually given for sample presentation. So to talk about the suspension, but this is the suspension that we are having. Ownership suspension.
We discussed about
Yes, sir.
So our braking system, the front one is the caliper one. Back one is the U brakes. Steering mechanism is actually similar to what we are seeing in a normal rolling wheel. There is no difference in the steering.
normal.
Yeah.
Yes, sir. Yes, sir.
There is no handling. Mechanism is also same.
Okay.
So CAE process. So the CAE computer aided engineering process was done in handlebars, frame, and wheels actually. And this was the thing that we, actually, this was also the process that was the problem definition. We have to define the problem first of all, and then this problem was converted into an AutoCAD, and then into analysis of it. So that was a phase. Post-time weight management. So these are the things that we couldn't execute properly, but some things that we done to cost reduction. Some materials we are considered on the scrap, and we depending on the available materials. So we were
actually marginalized into a workshop only, but we couldn't, rent any machines or something. So we were actually
We actually built it in our own workshop with the available materials around.
there's no such, weight estimation, affordable materials, free.
So it's all around weight around 90 kilos.
That is not an issue.
So actually in the design report we actually also stated that we were also trying to execute a seed logging system, which we couldn't execute.
We couldn't
There
able
was-
to.
Locking system.
That was actually we actually planned to clamp this seat into the back tire so that plug to the back tire with an electrical rocker system, like sensor, Saming sensor. So
Somebody
so we can
Only the
actually
rider
clamp
can
the seat to
unlock
the tire into this gap, and we are locking through this. So it will be difficult for someone to have.
you are connecting from the seat tube to the
No,
tire.
sir.
They are actually giving a clamp and bend this entire seat and lock this.
So much more.
And
You go, you do that and
Yeah.
Yes, yes. And installing lock system inside the
Yeah.
seat.
There.
Yes, sir.
But
Yes,
yes,
yes.
but we couldn't.
it's not a bicycle, motorcycle.
But we couldn't,
But top is but the top is good.
Thanks, sir.
so.
Scholarship.
I couldn't explain more about
That's fine.
Inspired, as I told you about that company, candidate. So actually,
Next step.
so solid system. Solid actually.
First aid box, sir.
Yeah.
Yes, sir. We
Can
can
we
we
use
use
the
builder
first
within
aid
all the specific things which can be added into it.
So this can accommodate like water bottles, umbrellas, small umbrellas,
Raincoats.
raincoats. So, in emergency situation, we can also add,
Do spare. Spare. Reflectors, spare reflectors.
And also, if
integrated system if possible.
Also, we can provide batteries inside it.
we want to convert it into electric,
Batteries,
We
we
can,
can
if we have
convert.
if you want to
convert
convert
this
electric in the future,
we have
we will provide
better
battery.
space for installation of that and the components, right?
Okay.
Sir, there will be a small video about how we actually, it's not a 30-second video about how.
Running shots.
Can you please one more day? I think videos are not good. Sorry.
So, sir.